Thanks everybody for joining today. And as Florian said, we're going to talk a little bit more about missions. First, I want to introduce you to InOrbit. This is InOrbit's executive dashboard. It provides a high-level overview of deployments across the globe. As Florian said, robot agnostic and industry agnostic, but something to provide an executive an understanding of, how are my robots performing wherever they are with high-level KPIs that can draw attention to where it's needed to be. One of these locations is the InOrbit Robot Space. So let's take a closer look at that. So the Robot Space is our concept store. You can see Florian down here, and right now he's in the middle. Hi, Florian. This space is where we work with our customers and our partners to demonstrate robot behaviors, where we can define missions, execute them, and then go and analyze the performance as we work with our customers to optimize their operations. So let's take a look at this from an operator's perspective. At InOrbit, we can make it easy for an operator to see a space and to understand where the robots are within that space. So here you can see our restocker robot, some other robots in the space, as well as smart infrastructure like cameras or a door. You can also see operational aspects of the space, like for instance, this zone in the middle that's highlighted, which is a single occupancy zone that only one robot is allowed to be in at a time. Now also, this obviously isn't how the robots see the space. So we can switch to that and also see the robot's perspective, built from its map that it's running on it, so that it knows where it is within the space and can navigate using all the normal robot navigation and perception. In addition, we can add other important aspects of the space to be easily seen, such as waypoints that Florian was discussing. And this provides an easy way for both the robot and for the operator to have a full understanding of the space, and allows these different layers of a location to be easily observed and enabled or disabled. Okay, so let's step into missions. Here you can see the missions that are happening in this space over time, with very actionable insights for them, such as their success rate, average distance driven, or the number of incidents happening per mission. And most importantly, you can drill down into different aspects of those missions, such as perhaps the different hardware models and which ones are performing better or worse than others. All of this is just at your fingertips as an operator who's looking to improve the operations of their facility. Because ultimately, all of our customers who are using robots are using those robots in order to accomplish something. And so we want to be able to measure and help them measure whether they're achieving those accomplishments, whether their operations are improving based on their investment in their robots. And then obviously you can drill down into other things, like we may want to only look at completed missions and get in some insights into those, or perhaps even drill down into a specific robot. And so here we're looking at our restocker and the work that it's been doing within Robot Space. Let's come down and look at one of these missions. And this is where we get into what is a mission. So a mission for an AMR and within InOrbit is a sequence of actions, or what we call steps. So steps could be anything like interact with smart infrastructure within a space, or visit a waypoint. Steps can even include expressions that are evaluated based on perhaps the status of some other aspect within the space, a different robot, waiting on an action from a user, such as after picking or restocking has been completed, or even an external system telling the robot what its next step ought to be. So now let's go to a little bit of a simpler mission, and we will execute it and see how InOrbit can help a robot go about its tasks. So here's a simple mission that's going to, where an operator needs to send some stock to the front. And so I'm going to come in here and I'm going to select my robot that I want to use for restocking, and I'm going to dispatch it. And I get confirmation that the robot has been dispatched, and we'll switch back, and you can see that now it is interacted with the door and opened it. It's moving through it, and it's working on its way to deliver stock to the front where a different operator would be present to unload it. Now, what if perhaps I'm in a warehouse, and in this warehouse where normally we would be sending stock, and here we can switch over to this view and you can see the robot doing its work. What if in this case, the normal stock location was obstructed for some reason? And instead of the stock needing to go to its normal location, I as an operator know that it needs to go to an alternate location for some period of time. And in that case, I don't want to have to go back to my IT team or to perhaps an engineering team to update the mission. I as an operator know where it needs to go, and I want to be able to make those changes on my own. And so here's we go back to the map and bring up our waypoints. We can see now that this robot is at the location shelf 1010, which is the first shelf on the first row within this facility. But perhaps this is the space that's blocked, and as the robot's leaving now to go back to its starting location, let's see what we can do about moving this waypoint so that the robot can visit a different location. So as an operator, I can easily select this waypoint. I can move it on the map to its new temporary location. I can save that. In this case, moving a waypoint, we need to confirm that it has that this is really what I want to do. It is. So I'll move that waypoint. I'll now exit my screen, and I can come back, and you can see here that the waypoint has been updated within the mission, and I'll dispatch this robot again. And you can see that the robot now is responding to the same mission that I dispatched the first time, but in this case, instead of visiting the original location with the original waypoint, it'll visit the new location that I was able to update as an operator with just some easy point and clicks of the mouse. Now let's go look at what a mission definition looks like a little bit more closely. For instance, if I was a robot developer and instead of needing to update the location temporarily for a mission, maybe I'm defining a mission altogether. And this is typically how you would do that as an engineer or as an IT technician, deploying the robots and defining the missions for the in the first place. This is a JSON document that many of you would be familiar with. And you can see that it'd be very easy to create these types of documents to define the robot behavior, thinking back to those steps that we looked at earlier where the robot had a sequence of steps that could be different things like waiting for a period of time or interacting with other smart infrastructure within a space. So we can switch back and see that now, yes, in fact, the robot did visit the new location that we asked it to. But perhaps instead of just a temporary update to where that location needs to be, we may at times want to completely update the mission and have the robot perform a different behavior permanently. And so we can switch over to this mission definition document. You can see here, it's the same one that we looked at before. And let's send this robot instead to a different shelf. And you can see I've updated the shelf number. And I forgot to stage my command, so I will apply the shelf. I'll apply that update. You can see it was applied successfully. We'll go look at the mission again, and you can see that the mission has updated, so it's now the new shelf location that I gave it. And again, we'll dispatch the same robot. And you can see that it's opened the door, and we'll head to the new location that we gave it. very simple way to update the configuration of a mission just through a simple CLI and JSON or YAML documents that we're all familiar with. So this is in-orbit missions and how we can work with both end users to help them define, execute, and analyze the behavior of robots within their operation and optimize those. In some cases, you may even have very advanced end users that have many different types of robots. In those cases, these same tools could be used to orchestrate the behavior of multiple robots operating within the same space and providing very easy observability of where those robots are, what they're doing, and their performance.